Okay, let's take a peek at how you're doing so far here. The first one here, we're adding, and when we add or subtract, we must have the same name. So I'm going to rewrite that one over here so that we can rename them. Bless you. What is our common denominator going to be here? Bless you again. If we look at the 8 and the 4, it'll be 8b squared. So what we do there, remember, is we do the numbers. The common denominator between 8 and 4 is 8, because 4 goes into 8. Then for each variable, we take the largest power, the larger of the powers. So what did we have to do to the 8b to turn it into an 8b squared? Just times b, yes. We didn't have to do anything to the 8, because that stayed an 8. We have to multiply b by another b to create b squared. So the 5x in the numerator must also be multiplied by b. So 5x times b is 5bx. If you had 5xb, that's okay too. Down here, what did I have to do to the 4b squared to turn it into an 8b squared? Times 2, good. 4 times 2 makes 8, and the b squared does not have to change. So we multiply the 3 times 2 to make 6. And now we're adding 5bx over 8b squared plus 6 over 8b squared. We combine the counts, so it's 5bx plus 6, which is perfect. 5bx plus 6 over 8b squared. Good. Any questions? Okay. Number 2 here, we're dividing, so that's going to require us to rewrite the problem. I don't have any room below, so I'm going to rewrite it over here. As multiplication, so the second fraction is going to get flipped over. We're taking its reciprocal. I'll erase that to kind of get it out of the way here for now. So then we can separate out the numbers if we want to. 7/16 and the 8 over 3. And what can we do with those? Okay. Perfect. Both 16 and 8 divide by 8, so I get 2 and 1. Then I can multiply. 7 times 1 is 7. 2 times 3, 6. Can I reduce that to 1 1/6? No, because I have variables in the problem. I can never create a mixed number when there's variables in the problem. So now I have to deal with my variables. I've got x to the third over y squared. I've got y to the fifth over x to the fourth. So we just combine those. This is x to the third, y to the fifth, x to the fourth, y squared. And then for our x, is that going to end up on top or bottom? Bottom, because the larger power is on bottom. And it's a power of 1, or just x. X to the 1. 4 minus 3 is 1. So x to the 1, or just x. Then 5 is, or the y is going to end up on top or bottom? Top, because the larger power is on top. And it's going to have a power of 3, because it was 5 minus 2. So 7y to the third over 6x. For number 3, we're just flat out multiplying there. So I can take out my numbers. 12 over 5 and 15 over 16. What can be reduced there? Okay. Perfect. Both 12 and 16 can be divided by 4. 12 divided by 4 is 3. 16 divided by 4 is 4. And? Perfect. Both 5 and 15 divide by 5. So 5 divided by 5 is 1. 15 divided by 5 is 3. Then we multiply. 3 times 3 is 9. 1 times 4 is 4. So the number portion of the answer is 9 over 4. And we'll pull out our variables. Well, we've got x to the fourth over nothing there. There is no variable in the numerator, in the denominator there. And the other one, there's no variable in the numerator. We just got x on bottom. So that's just x to the fourth over x, which means in our answer, x is going to go Top or bottom? Top. Power of 3. Because we think of that as x to the 1. 4 minus 1 is 3. So 9x to the third over 4. Now, these I didn't have up there for you to work on, but I want you to take a minute now and see if you can try to work those out. When you're working on these, you would want to reduce inside the parentheses first before you do the power. So that'll make that significantly easier. Let's take a peek. I know some of you are still working on these, but so for number 4 here, the first thing we have to do is reduce inside the parentheses. So dividing out in here, 28 divided by 7 is 4. X to the 5th divided by x to the 3rd is x to the 2nd. And y to the 7th divided by y to the 4th is y to the 3rd. This is one that actually does divide right out. You don't have to just reduce it like a fraction. It does divide out. The only way you would know that is if you started doing it and it worked out this way, that there's nothing left on bottom. So then to the power of 4, 4 to the power of 4 is 256. Very good. Now remember, you actually have to do that 4 times 4 times 4 times 4, or use the power key on your calculator. Now for the variables, x squared to the power of 4, what do we do with those powers? Times them. So that becomes x to the 8. 2 times 4 is 8. And it'll be y to the 12th. Good. Now for this next one, you go to divide it out, and it's not going to reduce down as simple as this one. This one is going to stay as a fraction. So the 24 and 40, reduce those down. What can both of those be divided by? 2 would work. That would give us 12 over 20. What else? Divide by 4 now. Gives us 3 over 5. So in our result, well, in the next stage, we have a 3 and over 5 as the numbers. So this is not going to reduce down to a whole number. This is going to stay a fraction. Now for the x, where's the x going to end up? Top, power of 3. Very good. And y is going to be bottom, power of 2. And now we can do that power of 6 to each piece. 3 to the power of 6? 729. X to the third to the power of 6? X to the 18th. We do 3 times 6 makes 18. 5 to the power of 6. Perfect. 15,625. Y squared to the power of 6. Y to the 12th. And that's it. Any questions? Okay. Well, today we're going to move from operations with simple fractions into operations with mixed numbers. So when we're working with mixed numbers, we not only have the fractions to worry about, but we have the whole number portion going with it. Now the good news is, you remember last class we've talked about this actually for a couple of classes. When we have variables in the fraction, we can never reduce it to a mixed number. It always stays as just a fraction. So if we're working with mixed numbers, there won't be any variables involved. So we're going to start out with adding. And remember, when we add, I'm not going to write it down again because I've put it up here a lot already this semester. When we add or subtract, we must have the same name. So if I have something like 3 1/6 plus 5 3/8, I'm going to set that up vertically like I always do when I add. And you'll notice I line up the fractions at the end of the number almost like they're the last digit of the number. And in actuality, that's what it is. The fraction is nothing more than the last digit at the end of the number. Now, before we can add these, just like any other fraction, we have to have a common denominator. Notice the whole number portion does not change. We're just changing the fraction. So for 6 and 8, what's our common denominator going to be? 24. Good. So what is this going to become up here? 4. Good. 6 times 4 to make 24, so 1 times 4 is 4. What's this going to become up here? It'll be 9. 8 times 3 to make 24, so 3 times 3 is 9. Now that we have the same name, the common denominator, you'll notice, by the way, that the whole number portion, again, did not change. Some people just rewrite the fraction when they rename it. I always rewrite the whole number too, otherwise I sometimes forget about it. So now that we have that same name, the common denominator, we can go ahead and add 4 24ths plus 9 24ths. Remember, we combine the counts, so 4 plus 9 is 13, and we keep the same name of 24ths. 3 and 5 make 8. Now, when we're adding mixed numbers like this, it does not stay that simple. We can run into things like this. What's my common denominator going to be here? 12. What's this going to become? 9. 4 times 3 to make 12, 3 times 3 to make 9. What's this one going to become? 10. 6 times 2 to make 12, so 5 times 2 to make 10. Now when we go to add, now we start on the right and work our way back to the left, just like we do with any of our whole numbers, any other number. 9 twelfths and 10 twelfths. We combine 9 plus 10 is 19 twelfths. Of course, what's wrong with that? It's improper. So if I convert that back into a mixed number, I have 1 and how many pieces left over? 7. So it's 1 and 7 twelfths. So just like with any other number, I'm going to keep the piece that stays in that place value. This is the fractions place, so I'm going to keep the fraction, the 7 twelfths. I'm going to carry the other piece into the next digit. I'm going to carry the 1 over to the next digit. So 1 and 7 is 8, plus 3 is 11. So 1, and I carry the 1 over. So 11 and 7 twelfths. So I might have 359 and 4/5 plus 187 and 2/3. So again, the 359 doesn't change, and the 187 doesn't change. But for my 4/5 and 2/3, what does my common denominator become? 15. Very good. What's this going to be? 12. 5 times 3 to make 15. 4 times 3 makes 12. And this one? 10. 3 times 5 is 15. 2 times 5 is 10. So we go to add. 12 fifteenths plus 10 fifteenths. 22 fifteenths. Which can be reduced to 1 and 7 fifteenths. Good. So what part do we keep? Keep the fraction. The 7 fifteenths we keep. We carry the 1. So now the whole numbers are going to work just like any other whole number. 1 and 9 is 10, plus 7 is 17. So 7 carry the 1. 1 and 5 is 6, plus 8 is 14. So 4 carry the 1. 1 and 3 is 4, plus 1 is 5. So 547 and 7 fifteenths. Any questions? Maybe let's try some in your notes here. Maybe try 2 of them actually. We'll try that one and this one. see how you're doing so far. So the first one here, we need common denominator between 6 and 8. That's going to be 24. Now, if you're really stumped, you could just do 6 times 8 and get 48, and that'll work. Just remember, you might have to reduce at the end, like we showed you last class. So what's this going to become here? 20. Good. 6 times 4 to make 24, so 5 times 4 is 20. What will this be? 21. Good. 8 times 3 for 24, so 7 times 3 makes 21. We go to add. 20 and 21 is 41 24ths, which is 1 and 17 24ths. Good. So we keep the 17 24ths. We carry the 1. 1 and 9 is 10, plus 4 is 14. So 14 and 17 24ths. How many of you had that one? Okay. No? What, did you carry and get you, or was it the common denominator?
I just think it's 14.
Okay. Okay. So reducing it back down. Okay. That works. For this one, we need a common denominator. What's that going to be? 70. So this is going to become 49. Good. 10 times 7, so 7 times 7. This will become 40. So we add 49 plus 40 is 89 70ths, which reduces to 1 and 19 70ths. Good. So we keep the 19 70ths. We carry the 1. 1 and 8 is 9, plus 9 is 18. So we keep the 8 and carry the 1. 1 and 3 is 4, plus 2 is 6. So 68 and 19 70ths. Any questions? Okay. When we subtract, we're going to follow the same process. So like 9 and 2/3 minus 6 and 1/5. Again, the whole numbers will not change, but we need to find common denominators for our fractions. The fractions, again, serve as just the last digit of the number. So for 2/3 and 1/5, my common denominator will be 15. So 2/3 is going to become how many 15ths? 10. 3 times 5, so 2 times 5. And 1/5 becomes 3 15ths. 5 times 3, so 1 times 3. And now we are subtracting. So again, we start on the right and work our way back to the left, like we always do. 10 minus 3 is 7 15ths. And 9 minus 6 is 3. Now, as we saw with addition, it doesn't stay that simple. We're going to run into things like this. 8 and 1/4 minus 5 and 5/6. So we're going to find our common denominator. It is going to be what? 12. And what's this going to become? Did somebody say it back there? 3. 4 times 3 is 12. 1 times 3 is 3. This is going to become 10 12s. 6 times 2, so 5 times 2 is 10. That's okay. So we go to subtract. 3 12ths minus 10 12ths. Well, we can't do 3 minus 10. Bless you. 3 minus 10 would give us a negative, and we don't want to do a negative within our number. So just like with whole numbers, we can borrow from the next digit. So we borrow from the 8, and we make that a 7. The difficulty here we have to be careful is, what does this become? 15. Very good. It's 3 plus 12 makes 15 12ths. Because what we borrowed is one whole object. And the denominator of the fraction tells us how many pieces are in that whole object. So since our denominator is 12, we have to add 12 pieces to our 3. So now we have 15 12ths minus 10 12ths, which is 5 12ths. 7 minus 5 is 2. Let's do another example of that. Let's do 18 1/3 minus 15 3/8. So again, must have a common denominator, which is going to be what? 24. This is going to become 8. 3 times 8 makes 24, so 1 times 8 is 8. This will become 9. 8 times 3 is 24, so 3 times 3 is 9. So again, we go to subtract. Going right to left, as always. 8 24ths minus 9 24ths is again a problem. So what are we going to do? Borrow from the 8. That's now a 7. This is going to become 32. We have to add 24 to that. 8 plus 24 is 32 24ths. So now 32 minus 9 is 23 24ths. We keep the same name. 7 minus 5 is 2. And 1 minus 1 is 0. So 2 and 23 24ths. Any questions? Well, we should have you guys try one. $43 3/8 minus 29 what do I put in here? 4/5. Go ahead and subtract that. We'll go over it in a minute. So, as always, when we add or subtract, we must have a common denominator. The whole numbers are not going to change, but our common denominator for the fractions will be 40. Good. This is going to be 15 and 32. Obviously, we can't take 15 minus 32, so we're going to borrow to make this a 2. This becomes 65. We add 40 to it, always adding the denominator. We borrow 1 here. The denominator tells us how many pieces we just... Should be 55. You're right. I'm sorry. 55. There we go. Sorry about that. There's my one mistake for the day. If that's all I make in one day, it's a heck of a day. So 55 minus 32 is 23 40ths. Now the 42 minus 29, we're going to borrow here again, make this a 12, and this is a 3. 12 minus 9 is 3. 3 minus 2 is 1. So 13 and 23 40ths. How many of you had that? No? Okay. That's okay. I screwed it up too. So if it wasn't for you guys, I wouldn't have made it. Okay, so next step is multiplying. And now remember, when we multiplied fractions, we had something like 3/5 times 2/7. We just multiplied straight across. Numerators times numerators. Combine the counts. 3 times 2 is 6. And we combine the names. 5 times 7 is 35. When we have mixed numbers, let's say we have 3 2/5 times 7 1/4. Multiplying mixed numbers is an extremely difficult process. In fact, if you went to any university and found 10 math majors and asked them how to multiply mixed numbers, I'd be surprised if even one of them can show you the proper way to do it. That's how we avoid it. Instead of working with the mixed numbers, we turn them into improper fractions. So 3 2/5 is going to become how many fifths? 17, good. 3 times 5 is 15, plus 2 is 17 fifths. 7 1/4 will become 29 fourths. 7 times 4 is 28, plus 1 is 29. Now at this point, this is multiplication of fractions. If there was something that could cross cancel, we could do that. Unfortunately, in this problem, there is nothing that cross cancels. So we're going to go ahead and multiply. 17 times 29 is what? 493 over 5 times 4 is 20. And we do have to reduce that down. 493 divided by 20. 20 goes into 49 twice. That's 40 with 9 left over. Bring down the 3. 20 goes into 93 4 times, which would be 80 with 13 left over. So that's 24 and 13/20. What's that? It was always that easy? Yeah, that's actually one of the worst ones. Anybody want to see how you would actually multiply the mixed numbers just for fun? A couple of you do? Why not? You don't have to write this down. I will never actually ask you to do this. But just like when we multiply like 37 times 23, you have to do the 3 times 7, but also the 3 times 3. Same type of thing happens here. You have to do the 1/4 times the 2/5, which is going to be 2/20 or 1/10. But you also have to do 1/4 times 3. So remember, when you multiply a fraction by a whole number, the 3 becomes 3 over 1. So that's going to be 1 times 3 is 3, 4 times 1 is 4. So it's just 3/4. Then we do the 7. You have to do the 7 times the 2/5. So that's going to be 7 over 1 times 2/5. 7 times 2 is 14. 1 times 5 is 5. So that's 2 and 4/5. Then you got 7 times 3 is 21. And now we have to combine those terms. We need a common denominator, which looks like it's going to be 20. So 1/10 becomes 2/20. 3/4, so times 5, so it'd be 15/20. 4/5 times 4, so that's 16/20. And we're going to add 2 and 15 makes 17, plus 16 is 33/20, which is 1 and 13/20. So we keep the 13/20. We carry the 1. 1 and 2 is 3, plus 1 is 4, and then we got the 2. So we get the same answer. Yeah, that's a long process, yes. Yes, there is. I think I'm going to stick to turning them into improper fractions and multiplying. So let's do another example of making them into improper fractions. So let's do 7 1/3 times, let's see here. Let's do 4 1/5. So you guys tell me what to do first here. Okay, so 7 1/3 will become 22 over 3. Good. 7 times 3 is 21, plus 1 is 22. 4 1/5? 21 over 5. 4 times 5 is 20, plus 1 is 21. Then what? Okay, we could just multiply across, but if you look closely here, we can reduce. We can cross cancel by 3 there. 3 divided by 3 is 1. 21 divided by 3? 7. So now it's a little bit simpler for us. 22 times 7, 154. 1 times 5 is 5. So 154 divided by 5. 5 goes into 15 3 times. There's nothing left over, so bring down the 4. 5 does not go into 4, so we leave a 0. So it's 30 and 4/5. Not too bad? Let's look at division in our last few minutes here. When we divided with our fractions, we saw on Monday that there actually is a process of dividing straight across with fractions. But we typically use that shortcut where you turn the second number into the second fraction into its reciprocal and you multiply. And that's the way we're going to continue with our mixed numbers. So if we're going to turn this into multiplication, it makes sense that we're going to turn the mixed numbers into improper fractions. So 8 1/3 becomes 25 over 3. 2 4/5 becomes 14 over 5. Now at this point, can I cross cancel the 25 and the 5? No, because right now it is still division. Once we turn it into multiplication, we can cross cancel. Now the 25/3 does not change. The first number never changes. It's always the number after the operation that is affected by the operation. So instead of dividing by 14/5, we're going to multiply by 5/14. Now we could cross cancel. Unfortunately, there's nothing here that cancels out. 25 times 5, 125. 3 times 14, 42. If you reduce that down, that is 2 and 41 40-seconds. Let's do this. 1 1/10. I'll have you try to divide that one out in your notes quick. Let's see how you're doing. Our first step is to turn them into improper fractions. So 8 4/5 becomes 44 over 5, 44/5. 1 1/10, 11 over 10. Now it is really tempting at this point to try to cross cancel the 44 and 10, but we can't because still division. So the 44 over 5 does not change. This becomes times 10 over 11. Now it's multiplication, and now we could cross cancel. What can we cancel here? 44 and 11 both divide by 11. So give me 1 and 4. 5 and 10 both divide by 5. Gives me 1 and 2. 4 times 2 is 8. 1 times 1 is 1. 8 over 1 is just 8. Any questions? Yeah. Yep, that works out. You can get the 440 over 55 and divide it out. Okay. So that's going to be it for today. There is a new quiz that is due tomorrow. That's Thursday at 11:59 p.m. That quiz is on the stuff that we went over on Monday, so I suggest you do that first. Then there is a new homework that is due for Monday. It's covering the stuff that we're talking about today and what we will talk about tomorrow as well. So with that, you guys have a great day. We'll see you tomorrow.